This section is going to talk about linear inequalities. So our objectives, we're going to solve linear inequalities graphically using the x-intercept method and algebraically. And we're going to solve compound inequalities at the end. So I put here a little remember. Linear inequalities are equations with the equal sign replaced with either less than, greater than or equal to, or less than or equal to. You can do the same operations to solve a linear equation. However, this is important. When you multiply or divide by a negative number, you must reverse or flip the inequality symbol. So let's work on this example. It says we will solve the inequality negative 2x minus 1 is less than or equal to x plus 2 graphically using the x-intercept method and algebraically. So graphically, I put here, we must understand that we are trying to find when the line y equal to negative 2x minus 1, so negative 2x minus 1 is this one right here, is less than or equal to, so is less than or equal to the line y equal to x plus 2. Oh, that's not what I wanted to do. It's a little bit too dark. Now, graphically, less than or equal to means this is going to be below. And the equal to part means where they intersect. So let's graph it. So I'm going to have negative 2x minus 1. So I know it's a line because it's a mx plus b form. So I only need 2 points. So I'm going to pick x equal to 0. So I'm going to have negative 2 times 0 is 0 minus 1 is equal to negative 1. And so for 0, I have negative 1. And then I'm going to pick 1. So negative 2 times 1 is negative 2 minus 1 is a negative 3. So for 1, I have negative 3. And I can follow the pattern. So it's going to be, just a minute, 2 down, 1 to the right. So 2 spaces down, 1 to the right. Or 2 spaces up, 1 to the left. And technically I would connect the dots. And for the next one, I'm going to also, it's y equal to x plus 2 right here. And I am going to, it's a line, so I also need 2 points there. So I'm going to do 0. So 0 plus 2 is equal to 2. So 0, 2, right there. And then I'm going to do 1. So 1 plus 2 is equal to 3. So 1 comma 3. And I'm going to follow the pattern there. It's a little off. And then connect the dots so I can get the line. Okay. So now I'm going to highlight here. So we want to know, so the line negative 2x minus 1, excuse me. The line negative 2x minus 1 is this one right here. And then the line, excuse me, x plus 2, but I'm going to make it a little bit lighter, is this right here. And we want to know when the yellow line is below or where it intersects the orange line. So I'm going to, below is right here, and where it intersects is right there. And we always answer in interval notation. So I'm going to write that down. Our answer in interval notation, always using the domain, is going to be lowest x, comma, highest x. So just looking at the red part that we've highlighted, that I've highlighted, our lowest x is going to be at this x value right here, which is -1. And it's an actual point. It is included as part of our answer, so it's going to be a bracket. And this part of the graph goes forever right. So forever right is going to be infinity, and infinities always have parentheses. Okay. The next one, the x-intercept method. We must understand we're trying to find when our modified line. So let's modify it first. So let me tell you what the x-intercept is. In the x-intercept method, the right side of the inequality is 0. So we need to modify our inequality. So we have -2x minus 1 is less than or equal to x plus 2. We need to move this and this to the left side so that we have a 0 remaining. So to get rid of an x, I'm going to subtract x from both sides, and I'm going to align it with what it's going to be combined. And I do not need to flip the inequality symbol, because I only flip it when I multiply or divide by a negative. So the inequality stays. And this is going to be -3x minus 1. And then this is just going to be 2. And then I'm going to subtract 2 from both sides. Again, in this case, I do not need to flip the inequality symbol because I did not multiply or divide by a negative. And so this is going to be -3x minus 3 is less than or equal to 0. So this right here is our modified equation right here. So we are trying to find when our modified line y equal to -3x minus 3 is less than or equal to the line y equal to 0. So let's highlight here again. So now we have different equations. So in the first, so now here we have this. And then here, the y equal to 0 is this one right here. So different from the first one, again, because we modified our equation. So now we want to know when the line -3x minus 1, so is less than, again, means below. Equal to means where they intersect. And we want to know when the line -3x minus 3 is below the line y equal to 0. And the line y equal to 0 has a special name. It is the x-axis. Okay, so let's graph these lines. All right, so here we go. Again, this is going to be -3x minus 3. Why is my yellow gone? I don't know. Okay. So it's a line. I can pick 2 points. So I'm going to pick x equal to 0. So this is -3 times 0 is 0 minus 3 is -3. So for 0, I have -3. And then for 1, I'm going to have -3 times 1 minus 3. That's going to give me a -6. So 1 -6. And I can follow the pattern. So it's going to be 3 down, 1 to the right. So 3 spaces down, 1 to the right. 3 spaces up, 1 to the left. able to connect the dots. And then the other one is y equal to 0. So y equal to 0, let me highlight it here. It's that same 0 that it's a little bit dark. So this just tells you that I really don't care what what x is. My y's are always going to be 0. So y are always 0 regardless what x's are. So I can pick 0 and 1. So 0, 0 is right here, and 1, 0 is right here, and that's not the best color to pick, so I'm going to switch them. It's going to be 1, 0. And again, the pattern would just be this right here. All of my y values are 0. I don't care what my x values are. And so for in this particular problem, the y equal to 0 line is this one right here. So you can see how different that is from the first problem that we did. And the negative 3x minus 3 is this line right here. But we still want to know when the line, the yellow line, is below, so right here, or when it intersects the orange line, so it intersects right there. And if you notice, hang tight, the x value right here is still negative 1. So it's still lowest x comma highest x. So it's still negative 1, bracket, because that's where they intersect. And then this is also still going forever right. So forever right is going to be infinity. The last method is going to be algebraically. So we're going to solve for x. So the original problem was negative 2x minus 1 is less than or equal to x plus 2. And just so that we can see them, so that's the original highlighted yellow and the originally highlighted orange. Okay. So I like solving for my variables, leaving them isolated on the left-hand side. That's just my preference. So I'm going to move this x, I'm going to subtract x from both sides. And then I'm going to add 1 to both sides as well. And again, I'm already aligning them up with what I'm going to combine. So I get, so negative 2x minus an x is, the first thing that I need to address is, did I flip the inequality symbols? I didn't multiply or divide by a negative number, so this stays. So negative 2x minus an x is negative 3x, and minus 1 plus 1 simplifies to 0. On the other side of the inequality, the x minus an x is 0, and 2 plus 1 is 3. Okay, so now I need to divide by negative 3, both sides. And so, do I need to flip the inequality symbol? The answer is yes, because I divided by a negative. And so negative 3 divided by negative 3 is an understood 1, times x is just x. And 3 divided by negative 3 is a negative 1. So x is greater than or equal to negative 1. This is your answer, but in set builder notation. And so in interval notation, x has to be greater than or equal to negative 1. So the lowest x that it can be is negative 1, and because of the equal to sign, we can put a bracket. And our highest x is infinity, and always with a parentheses. And we get the same answers. much quicker than graphically doing it by hand. Now, graphically doing it with a calculator might be just as quick, but yeah. Okay. Compound inequalities occur when two inequalities are connected by the word and or. Here we're going to concentrate on the word and. So I put a little note. Let me just read it. It says, instead of having two sides in an inequality like in the previous example, now we have three sides. However, the same methodology applies. What you do to one side of the inequality, you must do the same thing to the other two sides. Don't forget to flip the inequality symbol if you multiply or divide by a negative. So example, we will solve the inequality -1 is less than or equal to 1 minus x less than 2 graphically and algebraically. Okay, so graphically we are trying to find when the line y equal to 1 minus x is greater than or equal to the line y equal to -1. So greater than means above, and again, excuse me, the equal to part is where they intersect. And when it is less than, technically means below. So let me read that again. We are trying to find when the line y equal to 1 minus x is above or intersects the line y equal to -1, and when it is below the line y equal to 2. All right, so let's highlight here so that we can know what we're talking about here. So the line 1 minus x is this one right there. And then I'm going to highlight, sorry, I don't know why these are all opaque. So -1 is the line y equal to -1. And then this 2 is the line y equal to 2. So we're going to have to make 3 tables. And let's get to it. So I have x and I have y is equal to 1 minus x. So again, I'm dealing with lines, so I only need 2 points. So I'm going to pick an x equal to 0 and 1. So this is going to be 1 minus 0, which is 1. And that's a horrible line, but I think we get the idea. So 1, 2, 3, 1, 2, 3, 2, 3, 1, 2, 3. Okay, so for 0, 1, it's going to be this line right here. And then for 1, we're going to have 1 minus 1, which is equal to 0. So 1, 0, which is right there. And we can continue the pattern. So it's going to be 1 down, 1 to the right. So 1 down, 1 to the right, down, 1 to the right. Or 1 up, 1 to the left. And we connect the dots. Then the next one is an x and a y chart, and y is equal to -1. So again, y values are always going to be -1 in this case, regardless of the x's that you pick. So for 0, -1, it'll be here. And for 1, -1, it will be here. And we continue the pattern. And there's the line. Maybe I should do this a different color. Here we go. Now I'm playing with my colors. And then the other one is going to be the line y equal to 2. So again, x and y is equal to 2. This is a line. So y is equal to always 2, regardless of what x is. So 0, 2, and 1, 2 is right here. And I'm going to continue the pattern. I'm going to draw the lines. Now let's highlight here. Okay, So the line y equal to 2 was this one right here. The line y equal to -1 was this one right here. And the line 1 minus x was this one right here. So we want to know, so now that I have them color coded, we want to know when the yellow line is above or intersecting the blue line. Okay. So above or intersecting the blue line, so here it's intersecting the blue line, and then here it is above. But and I shouldn't say but, it says and I want to know when the yellow line is below the line y equal to 2. So below the line y equal to 2 means even though they intersect at this point, I'm going to make it an open circle because the equal to part is missing. And below is this part right here. And so my answer is where the shadings, my red and my blue shadings, overlap. So let me write that down. Hang tight. I just got inspired to do something. Excuse me. Overlap. Okay. So the x value right here is -1. So that's what I'm going to put. So it's still lowest x, comma, highest x. So it's still -1. But since I have this open circle, again, I'm missing the equal to part. It has to be a parentheses because that -1 is not included. But I still write -1 and I show that it is not included by using a parentheses. And then my highest x is this x value right here, which is 2. And since it is a closed circle because it had the equal to part, it's going to be a 2 with a bracket. And that's your answer, graphically. Now, algebraically. So let's do -1. I'm going to copy the problem. And so just so that you know that I know, it's still the original 1. Sorry. And then the 2, I had it in green. Okay. So here your goal is to isolate the x by itself in the middle. So let me write that down. Okay, so I need to subtract 1 from all the sides. So this is what we need to do. Subtract 1 from all the sides and ask yourself, do you need to flip the inequality symbol? The answer is no, because you did not multiply or divide by a negative number. So on a good day, -1 minus 1 is going to be 0. Excuse me, -2. Goodness gracious, I'm already thinking of the next one. So 1 minus 1 is 0, and then I'm just left with the negative x in the middle. And then 2 minus 1 is 1. Now, I need to divide both sides by -1 to get the x by itself, because it is still not by itself. Now, do I need to flip the inequality symbol? The answer is yes. So I'm going to go here. I need to flip the inequality symbol because I divided by a negative number. Now, negative 2 divided by negative 1 on a good day is positive 2. And then negative x divided by negative 1 is just x. And 1 divided by negative 1 is negative 1. So if you read this from the middle out, it would read as follows. X has to be less than or equal to 2. So, and x has to be greater than negative 1. In interval notation, we always write it lowest x, comma highest x. And so we have 2 and negative 1. Well, on a good day, negative 1 is lower than 2. So the lowest x is negative 1. And it doesn't have an equal to part in the inequality symbol. So it's going to be a parentheses. And my highest x is 2. And since I do have this equal to part right here, that means I put a bracket. And if you notice, we have the same answer.